Summary. A forward reaction is a reaction between reactants to become products, where reactants are on the left-hand side and products are on the right-hand side of the chemical equation. The reaction direction is from left to right, and it is denoted by an arrow pointing to the right. For a reverse or backward reaction, it is a reaction between products to become reactants. The reaction direction is from right to left, and it is denoted by an arrow pointing to the left. A reversible reaction is one in which the forward and backward reactions occur at the same time. Its chemical equation is denoted by a double arrow. Features of dynamic equilibrium. Dynamic equilibrium occurs when the rate of forward reaction is equal to the rate of backward reaction. The forward and backward reactions are ongoing. Reactant concentrations and product concentrations are constant. The system must be closed, that is, no reactants and products can escape. The reaction quotient QC is a fraction. In the numerator, product concentration is raised to its stoichiometric coefficient and multiplied by all other product concentrations raised to their stoichiometric coefficients. In the denominator, reactant concentration is raised to its stoichiometric coefficient and multiplied by all other reactant concentrations raised to their stoichiometric coefficients. QC provides a measure of progress of reaction at a point in time. It is used to predict the direction of a reaction. At equilibrium, QC is equal to Kc, which is the equilibrium constant. The equilibrium constant, as the name implies, is constant, so it doesn't change at a particular temperature. It has no units. The Kc expression or Kc formula is similar to that of QC, except that the concentration of each species must be its concentration at equilibrium. Kc applies to a system at equilibrium. It shows the extent or yield of a reaction. It is used to calculate the final composition of a reaction mixture. If Kc is greater than 1, products are favored. If Kc is smaller than 1, reactants are favored. If Kc is approximately 1, reactant amounts are roughly the same as product amounts. Only gaseous and aqueous species feature in Kc. Pure solids and pure liquids don't. When a reversible chemical equation is manipulated, Kc and its value must be changed. Predictions of the direction of a reaction. When Qc is smaller than Kc, the system proceeds in a forward direction. When Qc is equal to Kc, the system is already at equilibrium. When Qc is greater than Kc, the system proceeds in a backward or reverse direction. In an ice table, I is the initial concentration, C is the change in concentration, while E is the equilibrium concentration. Note that the ice table uses concentration, not number of moles. Determine which species is present at the beginning and write its initial concentration in the table. If a species is absent at the start, its initial concentration is 0. Determine the direction of the reaction. For example, the reaction may move to the side of the equation containing the species that is missing from the system at the start. To form the missing species, the species on the other side of the equation will have to be consumed. For change in concentration, be sure to include a minus sign if the species, whether reactant or product, is being consumed. Write a plus sign if the species is being formed. Write the appropriate stoichiometric coefficient of the species from the balanced chemical equation followed by unknown x. To get equilibrium concentration, add initial concentration to change in concentration. Write the Kc expression. Plug in equilibrium concentrations of species from the last row of the ice table. If Kc is small, that is less than 0.001, use the approximation method. Solve for x. Then substitute x into the equilibrium concentration expressions involving x.